Geometro Ninjas. Today we're going to talk about angles formed by secants, chords, and tangents with algebra. So yesterday we learned our rules. We had three types of angles. We had angles that occurred inside of our circle, angles that occurred on our circle, and then angles that occurred outside of our circle. You pair those three up with the first two we learned, central angles, which were congruent to their intercepted arc, and inscribed angles, which were half of their intercepted arc. And you pretty much get all the angles that can be created within our circles. So our instructions tell us we are going to assume any segment that appears to be tangent is tangent. Remember, tangent is a segment or line that touches our circle at exactly 1 point. So looking at number one, they want us to solve for x. So again, if it helps you, go ahead and highlight what's happening inside of the circle so you can have a better visual understanding. There's only 3 numbers here, so it's a little harder to mess anything up. But if they gave us multiple numbers, it kind of helps. So 3x plus 23 is an interior angle. So it happens inside of our circle. And for our interior angles, it is going to be equal to half the sum of our intercepted arcs. So in this case, our angle 3x plus 23 equals the 2 intercepted arcs, 75 plus 55 divided by 2. So we're going to follow PEMDAS. That right side, we're going to combine like terms on the top. So 3x plus 23 equals 130 divided by 2. Divide 130 by 2, 3x plus 23 equals 65. And from there, it just becomes our basic linear algebraic equation. We're going to subtract 23 from both sides, which gives us 3x equals 42. Divide both sides by 3. So x equals 14. Go ahead. So that's a great question. She asked, how do we know when to add our arcs or to subtract our arcs? So if it is an interior angle, so the angle occurs inside the circle. So this happens inside the circle, right? That is when we are going to add our arcs together. But if you scroll down a little bit at number 5, our angle occurs outside of the circle. So that's when we would subtract. I will. Any other questions? Hey. All right, number 3. I'll leave number 1 up there so you can see it a little bit longer. So number 3, we're solving for x again. Again, highlight what you've got. Help yourself out. And then my intercepted arc is this 140 here. So we've got 3 types of angles we can deal with. We've got angles that occur inside the circle, angles that occur on the circle, and angles that occur outside of the circle. So is this an inside angle, an on angle, or an outside angle? This is intersection on the circle. And just like our inscribed angles, if an intersection occurs on the circle, the angle is half of the arc measure. So our angle in this situation is 6x minus 38. And our arc is 140. and we're going to divide that by 2. So for an intersection on the circle, we're doing half. The angle is equal to half of the intersected arc. Divide 140 by 2, so 6x minus 38 equals 70. Add 38 to both sides. So 6x equals 108. And then our last step is to divide both sides by 6. So x in this case equals 18. Any questions for an intersection on the circle? It's just like our inscribed angle rule. The inscribed angles vertex on the circle is half of the intercepted arc. Good. Right. Number 5, solve for x. So now, again, highlight that angle relationship. If it helps, it helps. If it doesn't, that's fine. But get visual with it. Geometry is a very visual-based thing. So where does our angle intersection happen now? Inside the circle, on the circle, or outside of the circle? It is outside, so this is an exterior angle. Okay. That's our exterior intersection. And just like we had the question earlier, how do we know when to add our arcs or subtract our arcs? With an exterior intersection, we're going to do the difference. So it's the angle 7x minus 1 equals the big arc minus the little arc. So 161 minus 65. Why is it important that we do the larger arc minus the smaller arc? Right, we don't want to have a negative angle value because everything that we talk about is a positive angle. So once we start dealing with negatives, we're really going to mess everything up. So big arc minus small arc. So 7x minus 1, we're going to subtract 161 from 65 and get 96. (96) divided by 2 is 48. And again, we're solving for x. So we add 1 to both sides. 7x equals 49. And then our final step is to divide by 7. So for this circle, x equals 7. Zoom in a little bit so you can see a little better. Any questions on our exterior angle? Okay. Let's take a look at number 7. It tells us arc CB is 5x plus 41. Go ahead and write that on our diagram. Arc AD is 7x minus 19. And then angle AED is 89 degrees. They want us to find the measure of arc AD. So let's see which one we're dealing with. Okay, highlight our angles. And then highlight our intercepted arcs. First thing we've got to figure out, does our angle intersection happen inside the circle, on the circle, or outside of the circle? Is this an inside, on, or outside? Inside. So for inside intersections, the angle is equal to half the sum of your arcs. So our angle is 89, and we can even write this because they gave us points. Let's go ahead and write this whole thing out geometrically. So we know AED is equal to half the sum of CB and AD. So that interior angle is equal to half the sum of its intercepted arcs. So now we can substitute what we know. 89 is AED. CB is 5x plus 41. And AD is 7x minus 19. Our variable's on the right side, so we need to go ahead and deal with that too. So I'm going to multiply both sides by 2 so we can clear that denominator. So that 2 is going to be gone on the right side, and on the left side we end up with 2 times 189 is 156. No, 178. My apologies. 156 is the next one. And then 5 plus 7 is 12. And 41 minus 19 is positive 22. So we just combine like terms on that numerator. Subtract 22 from both sides. There's that 156. 156 equals 12x. Divide both sides by 12. So x equals 13. Okay, but unlike the first three, they didn't want x. They wanted the measure of arc AD. But now that we know what x is, we can substitute that value. So the measure of AD equals 7x minus 19. Substitute 13 in for x. So we get 7 times 13 minus 19. 7 times 13 is 91. And 91 minus 19 is 72. So we know the measure of arc AD is 72. Questions? Let's go ahead and move over to 9. Okay. They told us that arc BED, I know some of y'all are sleepy. Stay with me, is 15x minus 47. And then arc BD is 9x minus 1. Find the measure of angle CBD. So this is where they want us to solve for. Go ahead. Right, so we can't use one of our angles yet. We need to find out what x is. So my first question is, how did I know that BD went right to left? Or we started up at B. How did I know that B went and we went down to D instead of coming back around? Minor arcs are named with 2, which means that it is less than 180. So we're going to go the short way. And then BED, I went kind of counterclockwise because it was a major arc named with 3 letters. Don't let the major and minor confuse you. So like our classmates said, there's nothing we can really do to get to angle CBD next. Because if we set up that angle relationship, we'd get theta equals half of the intercepted arc, 9x minus 1, divided by 2. And when we set up that equation, the problem is I've got 2 different variables in our equation. So I can't solve one equation with 2 variables. But our classmate was correct. We know that the full circle is what? 360 degrees. We have a value for each arc in our circle. So we're going to set up our 2 arcs and set them equal to 0, our 360 first. So 15x minus 47 plus 9x minus 1 equal 360. So that is our counterclockwise arc plus our clockwise arc, which make up that full circle. Go ahead and combine like terms. We got 15 and 9, 47 and -1. So 15 plus 9 is 24. And then -47 plus -1 is -48. Look at me trying to do a triangle. Equals 360. Add 48 to both sides. So 24x equals 408. And then divide both sides by 24 to get x equals 17. Now that we know what x equals, it solves our problem. Now we can get rid of that second variable in our original equation. We're trying to find that angle measure. Okay, so we're still going to leave theta, but now we know x is 17. Okay, so it becomes theta equals 9 times 17 minus 1 all over 2. So 9 times 17 is 153. 153 minus 1 is 152. And 152 divided by 2 is 76. So we can still use our arc rules that we've learned previous to this. They could show back up as we work through it. Any questions? Questions are good. Live action. No? Right. Now let's do one more. Let's do one exterior, and then we can talk more offline if we need to. Okay. So they told me the measure of arc NJ is 170 degrees. MK is 5x plus 8. And angle MLK is 4x plus 3. Find the measure of angle MLK. So I'm going to go ahead and highlight the angles so I can see my intercepted arcs. So NJ is an intercepted arc. MK is an intercepted arc. Can you say 4x plus 3 equals 2 5x plus 8? No, you cannot. because that is only our inscribed angle rule, and this is an exterior angle. That only works for our inscribed. Okay, so this is an exterior angle. Exterior angles are equal to half the difference of their intercepted arcs. So geometrically, we would say arc MLK equals arc NJ minus arc MK over 2. And remember, we have to do the big arc minus the small arc so we don't get a negative angle measure. Yes, we're going to do that. Yep. Yeah, so when we know when to add or subtract is where does the angle occur? Does this angle occur inside the circle or outside the circle? Outside, so exterior we subtract. But if you go back to number 7, excuse me, where did our angle occur? Inside, so we add. Interior angles we add, exterior angles we subtract. And it is always half that. It's either half the sum or half the difference. Yes, sir? No? No? Decimals aren't a great sign. So we substitute what we know. MLK, 4x plus 3 equals 170 minus 5x plus 8 over 2. So we kind of substitute what we know. Parentheses matter on this problem. Okay, we've got to clear that denominator first. We're going to multiply both sides by 2. But I'm going to leave that numerator intact because it has a little bit more going on. Distribute 2 into both terms of your binomial. So 8x plus 6 equals 170 minus 5x plus 8. Now, this could be where you found your decimal. Okay, so guys, when we are subtracting a binomial, that minus sign is going to make a difference. The plus sign didn't matter, but this minus sign, just like we just distributed that 2, we have got to distribute the -1 into both terms of that binomial. So really, we have 8x plus 6 equals 170 minus 5x minus 8. So that minus sign turned both terms into negatives. All right, I want to move up to the top there so we get a little bit more room to work with. Okay, and let's just rewrite it so I don't do any tricky shenanigans down there on you guys. Try and do some magic tricks as we go. Okay, so we're going to combine like terms on the right side. So 170 minus 8, 8x plus 6 equals -5x plus 162. And I wrote x first because that's standard form. Add 5x to both sides. So we get 13x plus 6 equals 162. We're going to subtract 6 from both sides now. And we get 13x equals 156. And that 156 looks familiar. Okay, divide both sides by 13. So x equals 12. but they didn't want us to solve for 12. They wanted us to solve for MLK. So now we're just going to go ahead and substitute MLK. So the measure of MLK was 4x plus 3. What's up? We found x to be 12. So 4 times 12 plus 3. 4 times 12 is 48. And 48 plus 3 is 51. That was a good one. Any other questions on that? All right, that's going to wrap up our discussion on angles formed by chords, secants, and tangents with algebra. Thank you guys and have a great day.